Good day, viewers. You are welcome to our online class called Lead Tutors. And this class is to give you background knowledge, foundational knowledge in some science subjects. Today, we are going to be looking at physics, quantities in physics. As you can see, we have some quantities in physics. But before I go on that, I just want to let us know that physics itself is just a natural science where we study matter, motion, and energy. It's all about happenings in the universe. And so we want to talk about measurable quantities that we have in physics and their standardized values, the standardized values by which we measure them. Those are called units. So there are two quantities in physics. The first set of quantities are called fundamental quantities. Fundamental quantities, or you call them basic quantities. Basic quantities. These fundamental quantities are 8 in number. They are just 8 in number. They are not more than 8. And what are they about? Fundamental quantity are just quantities that I personally call them standalone quantities. They are quantities that are independent of other quantities that you can talk about in physics. And they are 8, just as I said, because of our time. So we're going to tabulate now, and we're going to see all the 8 quantities alongside with the units that we have. So I'm going to say fundamental quantities. So in front of them we will have the symbol, and here we are going to have the units. So number 1 fundamental quantity that we have is mass. And the symbol for mass is small letter m. The unit is kilogram, and that is kg in symbol. So number 2, we have length. Length is another fundamental quantity, small letter L, and the unit is meter, and small letter m. Then number 3, we have time. Time is also fundamental, small letter t, and the unit is second, and that is s. Number 4, we have electric current. Electric current is another fundamental quantity, and the symbol is I. At times we use small letter I, and the unit for that is ampere. Unit of electric current is ampere, capital letter A. Number 5, we have temperature. At times we call it thermodynamic temperature. We use T or we use theta, either of the two, to denote temperature. And the unit of temperature, especially thermodynamic temperature now, is Kelvin. We use Kelvin, thermodynamic temperature, and that is K. So we also have some other units like degree centigrade or Fahrenheit. But for thermodynamic temperature, it is Kelvin. And number 6, we have amount of substance. And the symbol for that is small letter n. The unit is mole, M-O-L for the symbol. So amount of substance. Number 7, we have luminous intensity. Intensity, S-I-T-Y, L subscript V. And the unit for that is candela. That is Ca for luminous intensity. And the last one is called magnetic flux density. Magnetic flux density. The symbol is capital letter B. And the unit for magnetic flux density is Tesla. The SI unit is Tesla, T. At times we use the unit Weber per meter square. Weber per meter square. So these are the 8 fundamental quantities that we have. They are not more than this. And you can easily study this and understand them. Most of the time in external exams, during the NECO exam or the WAEC exam, even the UTME, questions used to come out. In UTME, they can list some options and say which of the following is a fundamental unit or a fundamental quantities. One of these will be included. You can easily study this to understand. And so because of our time, let us move to the derived quantities. Derived quantities. The derived quantities. So these ones are more. Derived quantities are many. They are many because these are the quantities on whom the fundamental quantity rests. So we have combination of the powers of fundamental quantity or the basic quantities coming together to form these derived quantities. So we're going to have a table for these ones, derived quantities. We'll just talk about some of them, and probably we are going to allow the viewers to also do some research, and in the comment section you can look for more and post them there. Now the derived quantities, and this is the way we are going to do it, because we are saying that those derived quantity relies on fundamental quantity. So we are going to say derived quantities, and so in front of it we are going to have what we call derivation, how they are derived from a fundamental quantities. We have derivation, and here we are going to have the units of these quantities. So the first one we are going to talk about, don't forget I said there are many. The first one we'll talk about is the area. Area is a fundamental quantity because the derivation for area is length times breadth. Length times breadth. And if you look at the fundamental quantity, you can see length here. So the unit for area is meter square. Meter square. Both length and breadth are taken from the fundamental quantity whose unit is meter. Now it is denoted by capital letter A. Now number 2, we can talk about volume. Volume is another derived quantity. Capital letter V. Volume is another derived quantity, and we can say length times breadth. Length times breadth times height. Some will say length times width times height. And the unit for this is meter cube. You can see for length, for breadth, and for height, the three are brought together to make meter cube. Let's look at number 3. We'll talk about, and I'll call that frequency. Frequency is also a derived quantity. And the derivation for that, number of oscillations over time. Number of oscillations over time. The SI unit for this is hertz. For frequency is hertz, Hz. But we also have a unit per seconds. Per seconds for frequency. We can move on and to another derived quantities that I call force. Before force, let's talk about speed. let's talk about speed, and I have my reasons for that. Let's talk about speed or velocity. Speed or velocity. So I'll be talking about speed, and which is distance over time. And for velocity, we say displacement over time. Distance and displacement, we can use them interchangeably, but in physics, they do not mean the same thing. One is vector, displacement is vector, distance is scalar. But for the purpose of this class, let me not go there. So speed or velocity, the symbol small letter v, we use small letter v for that. So, and let me just say distance or displacement, as the case may be, displacement over time. That's the derivation. And so the unit for that is meter per seconds. The unit for speed and velocity is meter per seconds. Number 5, let's look at acceleration. Acceleration, small letter a. This is change in velocity over time. Change in velocity over time. That is the derivation. And the unit for that is meter per second square. The unit for acceleration is meter per second square. Now we can go to force now. Force, number 6. Force. The derivation for force is mass times acceleration. Mass times acceleration. This is taken from the Newton's second law of motion. But I'm not going there for the basis or for the purpose of introduction now for what we are doing. So just know that force, the derivation for force is mass times acceleration. And for mass, the unit here is kilogram. So we say kilogram multiplied by acceleration. We have done that of acceleration, meter per second square. Or the SI unit for force, which is Newton. SI unit for force is Newton. Once they ask the SI unit, but the other unit that we have is this. And this unit is very useful, very, very useful, most especially when we get to dimensions. We are going to make use of kilogram meter per second square instead of Newton. But bear it in mind, the unit of force, the SI unit of force is Newton. Let's look at more. Let's look at pressure. Pressure is another derived quantity, and the derivation is force over area. And if you want to write the unit, we have written the unit of force here. So that is, for force, we have Newton. We talk about Newton here. Newton per meter square, that is over meter square. Area is in meter square. So we can say Newton per meter square. Or you can write it in terms of kilogram meter per second square for the unit of pressure. We can say, since that of force is kilogram meter per second square, so we also have over meter square. So the meter square that is below, this meter square that is below in indices, if this power comes to meet this, is going to come as m1 minus the 2 here because of this division. If you understand a concept of indices, you will understand what I'm talking about. So that the unit of pressure now will be kilogram per meter, that is m raised to power minus 1 per meter per second square. Kilogram per meter per second square. Now let's go for more. We can talk about another one called momentum. 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 Momentum is product of mass times velocity. Product of mass and velocity. It is also a derived quantity, and if we write the SI unit for this, the unit is kilogram for mass, and velocity, we already have velocity somewhere here. We say meter per second, so kilogram meter per seconds for velocity. So let's look at one or two more. Number 9, we can talk about impulse. Impulse means change in momentum, and it is product of force multiplied by time, Ft. So there we can say the unit is, for force we said Newton. It can be Newton seconds because this is force and time. But for the purpose of dimension, we can go further and write the unit for force, which we said earlier on that it is kilogram meter per second square multiplied by time. Again, that means we're going to have times another seconds. Seconds raised to power 1. So in indices, we know what will happen. For s, it is -2 plus 1, and that is -1. So it can be -1. We already have 9. We still have many of them. We can talk about number 10. We can talk about Young modulus or modulus of elasticity. So either you call it modulus of elasticity. So modulus of elasticity, we say stress. We say stress over a strain. Stress over strain. So stress itself is another derived quantity. Stress itself is force over area. Stress is force over area. Stress is force over area. And so, forget about strain now. That is just extension over original length, because extension is in meter, original length is in meter, which we cancel out. Strain does not have unit, but stress has. So let's talk about that of stress. Force over area. So we can write for force now. Where is force? We already have, we can say Newton per meter square in terms of SI unit, or for the purpose of dimension, we can say for force, we can say kilogram meter per second square, then another meter square, that is per meter square, that's times m raised to power -2. So this is m raised to power 1 minus 2, that is -1. So we can say m kilogram m minus 1 s -2. And if you look at this particular unit, is almost the same as that of pressure. So we can say the modulus of elasticity have the same unit as pressure. If we look at it, kilogram per meter per second square, kilogram per meter per second square. We also have more. We can talk about energy or work or energy. Now we use these two interchangeably in physics. I'm not going to disturb you on the differences now. They do not have the same definition. They have some differences. But for the purpose of this class, I'm going to talk about work or energy as if both are the same. And that I'm going to use a derivation, force force times distance. Force times distance. And that is Newton meter. Newton meter. And for the purpose of dimension, we can use that of force that we have been using, kilogram, meter per second square multiplied by distance, that is another meter. So we have 1, that is m raised to power 2. So we have kilogram meter square per second square. That is the unit for work or energy. Another one is power. We can go on and on and on, but because I also want you viewers to also do your research, find out some other derived quantities so it can help you as well in your private work. So you can also go ahead, begin to search. You can go through your textbooks, you'll find some of them there. You can check some other sources, you'll find some of them there. But these are the ones we're going to talk about in this class. So please just help us to like. You can also help us to share for other students who need all this information for their exams to be able to know them. But that is all we're going to be talking about for this class. Thank you for listening. See you in our next class. You are welcome.